So hello there guys, how you all are doing? I hope you all will be doing fine. Welcome back to Rejoin Tech. We are again back with a new video in Leetcode playlist and this time about finding the maximum element in array.
Hope you enjoy the show.
This is going to be a really quick and easy video. The first one, as always, will be going through naive solution, which will be big O of n square.
I hate this.
Later, we'll make it efficient, we'll bring it to linear time complexity that will result it to be big O of n. So without further ado, let's dive into the video. If you like the content, kindly subscribe to the channel, like the video.
Please like me. Please.
If you have any doubts, any feedbacks, anything regarding that, kindly leave a comment on the video. That will help me a lot. So let's start the code with the naive solution in which the time complexity can go as long as big O of n square. So I have created all the boilerplate code. We just need to fill up the function. So I'll make the fonts little bigger. I hope this will be clear. Yes. So first of all, we'll create two nested. So here I am first of all writing the code. After that, we'll do a dry run and you will be able to easily understand it. So it will be int I is equals to 0, I less than arr dot length I plus plus. We'll make a variable here that is boolean. Let's name it as flag and we'll make it as true. Now we'll have one more nested loop inside it, which will be int j, which will be again 0 because we don't want any efficiency in this code. It will be again, it will be j, which will be again less than arr dot length. Now here we'll check if arr of j is greater than I, will make the flag as false. If arr of j is greater than arr of I, will make the flag as false. And will break the loop as well.
Do it, and I'll break the loop.
Now, if this is flag, we'll return arr of I. So code seems fine. Let's quickly do a compilation of the code to check whether this gives us the correct answer or not. Here the largest element is 87. So this is correct. Now let's quickly do a dry run that how this code is performing and why we have all these nested loops and boolean variables. And trust me, it is really easy to understand. So first of all, let's do a dry run on this particular array. So here it will be like for first term, for the first loop we are running for int I is equal to 0, I less than arr dot length. So in our first loop, I value will be obviously 0, the element will be 2. So how it will run is that now again it will check j is equal to 0. So this one, the output for the first loop will be is 2, that is arr of j, that is arr of 0, less than 2, that is arr of I, which is again 0. So this is not equal to true. So we will come out of this loop and we'll go again back to j wala loop. So now this time it will check whether arr of j, which is 1 this time, is less than arr of I or not. So arr of j, that is 1, is 54, that is our second element. It is obviously greater than 2. So we'll make the flag as false and we'll break out of the loop. Now what will happen when you break out of this loop? It will go into the outer for loop. So now I will be 1. So this time again we'll start with I as 1. So this one will be 54 and j will again start with 0. J will again start with 0 in this loop. So this will be 2. Whether 2 is greater than 54, this is wrong. So now J will again iterate in the inner for loop. This will check whether 54 is greater than 54, which is again wrong. Now the third element will come, whether J, that is ARR of 2, that is 21, whether it is greater than 54 or not. It is again false, so it will again come out of the loop. Again fourth element will be 54, which is again false. Again it will break, come out of the loop. Lastly, it will check whether ARR of say 5, that is 4 or 5, whatever, that is 87, whether it is greater than 54 or not. So it's checking. So this will be true this time. So what will happen? Flag will be set to false and the loop will break. So I will now become ARR of 2, that is 21. So again loop will go on. Now let's try for the time when lastly I comes at the 1, 2, 3, 4, fifth element, that is 87. So what will happen this time? Again the loop will start with y value as 0, that is 2. It will check again whether 2 is greater than 87 or not. It is not. Then it will shift again to 54. It will check it's false. Then 21. Then again 54. Then again 87. So again it is also not true. So it won't break. Again lastly 5 and lastly 4. So all the time the loop didn't break. So the flag that we set as true will be remain true in the case of 87. So we got our largest element, and this time there is this check if flag, that is we can also write it as if flag is equals to true. It will check ki if flag equals to true, it will return the ARR of I, that is our largest element. So this was the naive solution, and we actually don't want it. It was just for the sake of your understanding.
What?
That how we can write the naive solution as well. Now let's quickly jump into the efficient solution, and trust me, that will be really more understandable than this one.
Trust.
So let's again run this one. Let's see if we are getting the same output or not. So yeah, this is again the largest element is 87. If you want to even give the index of the element, you can easily do that. You can just remove the ARR of I and just output the I. This will give you the index of the element, that is 4th. So let's quickly code the efficient approach as well. In this we will have the time complexity as linear, that will be big O of n, not more than that. So let's code it out, then we will go through it and understand how it is working, and it's just barely 3 to 4 lines of code, and it's pretty easy and a very interesting concept to learn. We will create a variable that is int res equals to 0. Why we are making it as 0, we'll learn it soon. Now we'll have this for loop. It will be int I equals to 0, I less than ARR dot length I plus plus. Here we'll have one check, that is if ARR of I is greater than ARR of res, then update the res equals to I, and lastly we'll return ARR of res. This was the efficient code. Now let's know how it is performing. So that is a normal psychological concept that, say for example, something that is bigger out of them, we don't need to calculate them all the time. So if for example 54 is bigger out of them, we can take 54 out of it as output of these three, then run 54 with these all and check which one is greater. So this is the whole concept. So that is what we are doing. So first of all, we are assuming that the 0th index is the largest index. That's why we kept int res equals to 0. So we made largest as 2. Now what we are doing, for int I is equal to 0, I'm sorry, it should be 1.
For that, I'm sorry.
Why? Because 0 we are already taking here. So what we'll do, for int I equals to 1, if ARR of I, that is the first element which we are calculating, is greater than this particular element, then update this element to first element. So this is how it will perform. So it will check if 2 greater than 54, that is false, then make res as 2. So this will become the new res. 54 will become the new res. Now what will happen for the next time? It will compare 54 with 54. That is again not true. So it will remain same. Then it will compare 54 with 21. Then 54 is greater. It wouldn't, change the res. Res will be same. Again it will compare 54 with 54. It is again not greater. This condition will be false. So it will again be same. Now it will compare 54 with 87. So what will happen? 87 is greater. That is ARR of I is greater than ARR of res. So it will again change the res to ARR of I. So now the res will become this element, index of this element. Now next iteration it will check with 5, then with 4. So at all the times the res at last will become index 4th, which is 87, and it will be evaluated to true. So lastly we'll get ARR of res, that is our largest element, that is 87. So this is being done in just one traversal.
One time.
It is just checking out key out of these two elements which is larger, so this is larger. Now it will check out of these two which is larger, this is larger. It won't update. So it is all the time checking one larger element with all the other elements. If the other element is larger, it is changing the larger element to this element. Now again it is checking with all other elements. So this is how our code is performing. I'm pretty sure it's easy to grasp.
Hope you enjoyed the show.
If not, write it down in comments. I will explain it probably using my tablet and all. So if you like the video, kindly subscribe to the channel and let's learn together. See ya soon.